So good day everyone. I am Kitul Human, BSMA, and for today's video, we're gonna task to answer the two given problem from electrical circuits. So let's take a look. For this problem, number one, so the question is find the voltage at the voltage source in these circuits, which is the loop A, B, C, and D. So using the KVL or the Kirchhoff's voltage law. So according to Kirchhoff's voltage law, the algebraic sum of the voltages around any closed path is equal to 0. So we use the directions of the flow of the current through clockwise direction. So let's start for the BS. So first we need to make a equations using the Kirchhoff's voltage law. So first, let's start in the 20 volts. So when we enter to the 20 volts, so the direction is clockwise. So we enter to the higher potentials, which is the positive. So let's write for the positive 20 volts, and next is they travel to 50 volts, so it enters to the higher potential voltage, so it is a positive 50 volts. Then next it flows to these directions into 30 volts. So as we notice that it enters to the lower potential, so it is a negative 30 volts. Since they travel to this path to voltage source, so they enter to the lower potential or the negative. So negative voltage source, and then it enters to the 10 volts, which is the lower potential, or it is a negative 10 volts. So it is equal to 0. So this is the questions from these circuits. So next is we have to combine those same sign. So 20 voltage, we can add the 50 voltage, so 70 voltage, so 30, and negative 10 volts, so is equal to negative 40 volts, and then the negative voltage source, or the BS, is equal to 0. So we can subtract the 70 to 40 volts, so the answer is 30 volts minus the BS equal to 0. So in order to get the voltage source, we can transpose this negative voltage source in this side to 0. So BS is equal to 30 volts. So the answer for the voltage source, so we have the 30 volts, and according to the Kirchhoff's voltage law, so the sum of all the voltage drop is equal to 0. So when we plug in this 30 volts to this equation, so the answer is 30 volts minus the 30 volts, so is equal to 0. So let's say 30 volts for this equation, so Bs is equal to 0. So 30 volts minus the 30 volts is 0. So 30 minus 30 is 0 is equal to 0. So therefore, this answer is correct. So that's all for the problem number 1. So for the second problem, so this is the second problem. So find the voltage 1 or the V1. So here in the circuits, in this diagram, we have the 4 voltage as a voltage source, and we have the given also the R1. So here in this 10 ampere, we have 16 ampere also, and we have the resistors, which is the R1, R2, R3, and R4. So since in this circuits, no, so we have the loop at A, B, C, D, E, F. So using the KBL or the Kirchhoff's voltage law, so we can using the KBL at loop A, B, C, D, E, F. So we have already given the 400 voltage, which is the source. So let's start for the source. So when we enter to the source, so the flow of the current is in negative, or the flow of the voltage is in negative, so which is the lower potential to higher potential. So it is a negative 40 volts. And then so as it enters to the V1, so V1, so as you can see here, it is a higher potential, or the higher potential to lower potential, so it is a positive V1. So next, the flow of this current is a, or the voltage, it travels to the loop of the A, B, C, D, E, F. So as you can see, it travels to the loop. So it here in C, so you can see there is a given 16 ampere. So plus 16 ampere, and since this resistance has a 3 given, so we can multiply the C, and then next it travels to the resistors in the this corner. So here is the, so as you can see, there are a current, which is the 4 ampere, so we can add plus 4 ampere, and then this resistors has a equivalent of 2, so we can multiply it by 2, and is equal to 0. So we can I don't have to use this inside of these circuits, because we only have to take the voltage from V1. So we have to know this loop to ABC, DEF only. And then so here it is, negative 40 volts, plus the B1, so plus the 16 times 3, so 40, 48, and next is the 4 times 2, we have a 8, so it's equal to 0. So 40 Next, so we can add the 48 and 8 to negative 40 volts plus 56 plus the B1 is equal to 0. So hence this is a negative and positive sign, so we can subtract. So the answer would be 16 is equal to, so I directly transpose the V1 here. So negative, so we can so V1 is negative 16 volts. So let's try to check if it is a correct, as according to the Kirchhoff's law, the algebraic sum of all the voltages are in a closed path is equal to 0. So question. So when we plug this value to V1 in this equation, so 40 negative 40 volts plus 56 plus V1 is equal to 0. So the value for V1 is negative 16, so negative 40 volts plus 56 plus or negative 16 volts is equal to 0. Since as we can see in this questions, so we can have to combine the same sign, so negative and negative, so it becomes a negative 56 volts. So we can add the plus 56 is equal to 0. So as you can see, negative 56 plus 56 is equal to 0. So 0 is equal to 0. So this is the correct answer. With V1 is negative 6, because according to the Kirchhoff's voltage law, so with V are the voltage drop, or the voltage drop for the at loop, outside loop, or the ABCDEF. So we can have the is equal to 0. So yeah, the answer is V1 is equal to negative 16 volts. So that's all for the explanations about the two given problems. So that would be all, and thank you.